Okay, so welcome and good morning, all of you, to this session. Hope you are enjoying the other sessions of this international conference on nonlinear applied analysis and optimization. Today is the second day of the conference, and next we have an invited talk from Dr. Sujit Das from the Department of CSE NIT Warrangal. The title of his speech is Picture Fuzzy Set Based Decision Making Approach Using Dempster-Shafer Theory of Evidence and Gray Relation Analysis and its application in COVID-19 medicine selection. Yeah, I am sure it is going to be a very interesting talk. So, I am Dr. Pratik from the Department of CSE IIT BHU Varanasi, and I would also like to take this opportunity to briefly introduce the speaker before he starts his presentation. Okay, so, Dr. Das is working as an assistant professor at the Department of CSE NIT Warrangal for the last 3 years. His research interest includes fuzzy set, hybridized fuzzy set, fuzzy soft set, multi-criteria decision making, robust and optimal decision solution using soft computing, artificial intelligence, evolutionary computation, and machine learning. He has published around 50 papers in the refereed journals and conferences, and he has over 950 citations. He has also achieved 3 conference best paper awards in CSO 2014 Beijing, FICTA 2015 held at Durgapur, and Forbes 2018 at Kolkata. He has also organized a number of faculty development programs and conferences. With this small introduction, I would like to request Dr. Das to kindly start his presentation.
So thank you, sir. Thank you for this nice and brief introduction. So I am really thankful to Professor Dr. Tanmoy Som sir for inviting me to this nice platform on this international conference on nonlinear applied analysis and optimization ICNAAO 2021 that is being organized by Department of Mathematical Sciences, IIT BHU Varanasi. So thank you, sir. Thank you once again. So with this, I will start my session. So during the presentation, to avoid any distractions, simply I'll switch off my video and then again I'll switch it on after the presentation. So may I know my screen is visible or not?
Yes, sir. Your screen is visible.
Okay. So this half-an-hour session is all about this picture fuzzy set-based decision-making approach using Demstar-Shafer theory of evidence and GRA and its application in COVID-19 medicine selection. So we published this paper just only a few months back, that is published in Soft Computing Journal. So quickly I come to our proposal, actually what we did in this particular paper. So we know that we are in a situation where COVID-19 has affected the entire world, and most of the things around the world, since either it is stopped or they are suffering. So ultimately, so that preferable medicine selection, so it has become very much challenging task for most of the medical practitioners, and at the same time, it is the most necessary that medicine must be there. And once some patients are suffering from COVID-19, then if we give them, if we provide them some good medicine, maybe the situation will improve. So from based on our this kind of thinking, we thought that how we can do, how we can contribute towards this COVID-19. So mainly, so we have proposed a decision-making approach here. So that is based on this picture fuzzy set, Dempster-Shafer theory of evidence, and GRA. And we all know that what is PFS. Ultimately, that is an extended version of, simply we can say, that intuitionistic fuzzy set. And we know that in 2014 that Guang developed this picture fuzzy set concept. So simply as a generalized form of this fuzzy set and intuitionistic fuzzy set. So in this proposal, so mainly we'll try to explore that neutral membership grade. We know that in this picture fuzzy set, the picture fuzzy set is associated with 4 types of membership grade. That is positive membership grade, negative membership grade, neutral membership grade, and abstain membership grade. So, and we know that the neutral membership grade, actually I will come to that later on. So if we attach that neutral membership grade to either with the positive membership grade or with the negative membership grade, then perhaps we may get the maximum advantage from these picture fuzzy sets. And ultimately what we have done here, so based on this motivation, that what we found, that many of the researchers simply they are utilizing the neutral membership grade simply as this positive membership grade or this negative membership grade. But here we thought, why not that we can associate or we can explore the neutral membership grade, and some things from the neutral membership grade we can associate it with the positive membership grade, and something we can associate with the negative membership grade. So that was our main motivation, and we tried to explore that neutral membership grade can be associated with this probabilistic uncertainty that which can be measured by this Dempster-Shafer theory of evidence. Here we have proposed a fuse operator. So this is for basically for the aggregation purpose, and we have used GRA here to measure the performance among the various set of parameters, basically which are in conflict and contradiction with each other. So ultimately, we proposed an alternative group decision making approach. Now, as I said, that why we need PFS. So basically, in PFS, so the PFS approaches are found to be much more appropriate or suitable in those cases when someone contains more opinions like yes, no, abstain, and refusal. So this is the main foundation behind this PFS. Yes. So this was the definition for this picture fuzzy set, as I told earlier. So in picture fuzzy set, so that membership grade will be there. This is the positive membership grade. This is the negative membership grade, and this is the neutral membership grade. And another membership grade is also associated there. That is called refusal. That is refusal membership grade. We can compute in this manner. Yes, now that is the way to how we can compare the various picture fuzzy numbers. So using the score value and the accuracy part here, we can compare in these various ways. Now regarding the picture fuzzy set, since this is picture fuzzy set we are utilizing in this particular paper, so we need to know regarding something more regarding the picture fuzzy sets. Now simply in PFS, what the authors have divided, simply the hesitation margin of IFS, they have divided into 2 terms. One is the neutral membership degree, and second one is the refusal membership degree. Now, since the hesitation margin is divided into 2 parts, so when the both of this neutral and refusal membership grade are 0, then ultimately these hesitation margins become 0, and simply the PFS returns to this fuzzy set. Again, you know that sometimes using the fuzzy set and intuitionistic fuzzy sets, we find it so much difficult that to express the situations when human thoughts involve more options. So as I told earlier, like yes, abstain, no, and refusal kind of things. So in these particular cases, so PFS is found to be more preferable to handle this type of situations using the positive membership grade, neutral membership grade, negative, and the refusal membership grade. Now we'll come to this Demstar-Shafer theory of evidence. So we know that Dempster-Shafer theory of evidence, this is a mathematical theory of evidence. Initially, Dimstar introduced it in 1967. Then Shafer in 1976 extended the Dimstar concept into a mathematical theory of evidence, simply where it remains classic in the belief functions. So that's why combination of both, it is called, this is the theory of evidence. Now, since Dempster-Shafer theory, what we can say that Dempster-Shafer theory states or assumptions between a universe of discards U, and simply we can say that a corresponding statements into a group of propositions where only one statement is true. And simply the propositions are assumed to be that complete, mutually exclusive, and exhaustive. And it is used to solve the problems where there may be a chance that a different evidence will lead to some different result. And since we are dealing with the Dempster-Shafer theory of evidence, so very simply, I want to say that what is the difference between this DS theory and the probability. So in traditional probability theory, evidence is associated with only one possible event. But in DST, Dempster-Shafer theory, evidence can be associated with multiple possible events. So again, so where I can simply say that where the evidences are sufficient enough to permit the assignment of possibilities to all the single events, then perhaps the Dempster-Shafer theory model, it may collapse to that traditional probabilistic formulation. And these are the three basic concepts behind this Dempster-Shafer theory of evidence. So one more thing, one important feature I want to say regarding this DS theory, that DS theory, main one important feature is like that this model actually is designed to cope with various levels of precision that is regarding the information, and basically here no further assumptions are required to represent the information. That is the most important fact regarding this Dempster-Shafer theory of evidence. So here we are finding three main functions are there. One is BPA, basic probability assignment function. Second one is the belief function, and third one is the plausibility function. Simply the basic probability assignment function, it is a primitive of the evidence theory. Simply we can say that BPA, DPA does not refer to probability in the classical sense. And at the same time, BPA that defines a mapping of the power set to the interval between 0 and 1. Now, this is the definitions for this basic probability assignment functions. So simply we can say that basic probability assignment functions, that is PF on this 2 to the power u, that is the here a power set, simply it belongs to 0 to 1, and here we can find out, here if we see that kappa with the proposition and PF kappa, this is the evidence support of K, and ultimately summation of all these things will be 1. So where kappa belongs to this universe of discard CU. And obviously that once it will be this null, then obviously once there is nothing, so this it is called the degree of ignorance, and ultimately this PF kappa, this once it is greater than 0, that is called the focal elements of this basic probability function, which is probability assignment. And so quickly I'll want to come to our proposal. So this this is the belief, plausibility, and uncertainty. So so in order to measure the uncertainty of an event, simply Dempster-Shafer theory applies an interval, that is the interval of belief and plausibility. As you know that belief is a measure of the strength of evidence in support of a subset, and it represents the evidence we have for directly, whereas actually the plausibility function that represents the maximum share of evidence that we could possibly have. So from this, I have an example. So from this example, clearly we can get that what is actually the belief function and the mass function. So here we have considered these three symptoms like high fever, dry cough, and this tiredness. So and then the patient is suspected to be affected by COVID-19. So here this is our frame of discernment. This is beta, gamma, and delta, and we have considered the evidence M of this COVID-19 has been collected and represented by this basic probability assignment function. Now see, so this is our this basic probability assignment function. So simply and summation of all these things ultimately will be 1. Now how we are finding the degree of belief? So belief degree easily we can find out. So for beta exactly it is, now see for this beta gamma it is 0.25. How it is coming 0.25? Now this is 0.5, 0.5. Okay, so this 0.5, 0.5 once we are considering. So so actually what we are getting here now, let us check. So ultimately it will become 0.25, and ultimately it will. So similarly we can find out the plausibility. Now you can check how the plausibility is becoming 0.75 here. So ultimately, so it is beta, that means 0.25. So similar but actually, so you can find out that how we can calculate the degree of belief and mass functions. So in this example, easily we can get it that we can compute it easily, the degree of belief and mass functions. So quickly I'm trying to come to our proposal. So ultimately the Demstar, this rule of combinations. So basically whatever we have seen earlier, that the based on the DS theory, the evidence, belief, possibility and the uncertainty of a singleton event can be calculated by the basic probability assignment functions which we have shown earlier. But what will happen when 2 or more events are present? Then we need to apply this Demstar rule of combination. Now this is the Dimstar rule of combinations. So this is the expression for this Dimstar rule of combinations. So here two evidences are there. One is kappa, second one is psi. So based on that, so using this expression, we can calculate the Dimstar rule of combination. And here this is I, this is the basically conflict combination of the evidence. So this simply we can say this is the conflict percentage. So now this example, from this example clearly we can get that how we can find out this combination of these two evidence. So here we have considered that two teachers are there to evaluate the 100 number of the students of a particular class. So as per the evaluation of teacher 1, 50 students scored grade X and 30 students scored grade Y. And similarly for teacher 2, 40 students scored grade X and remaining 40 students so either X or Y. So now based on that we have calculated, see here, so this PF1, this is one means teacher 1, this is for teacher 2. So as per our statement, so it is PF1x 0.5, it is 0.3. So similarly for the teacher 2, it is 0.4 and also PF2xy, it is 0.4 as we have mentioned in the statements. Now we can easily find out that how we are finding PF1 to x 0.2 using these two, we are getting it this. So similarly, we can find out that how we are finding that PF2xy, and once we are multiplying this PF1x 0.5, so by ultimately we are getting multiplying these two, we are getting the value 0.2. So similarly, we are getting the other value. So in this way, we can combine that particularly the Dempster-Shafer theory for two evidences. Now, after combining, how we can find out that what is the probability function, this PF for X, basic probability assignment functions, and what is that for Y. So using the expression, what we have given earlier, using that expression, we can compute it. Here ultimately this will be 0.66. So as you have seen, that conflict percentage that was 0.12 and ultimately 0.2, 0.2, 0.1 and 0.08. Simply this is coming. Since we are calculating X, so we are considering this is 0.2, this is 0.2, and this is 0.1, and this is 0.08. So here we have found that the value of R, this one, that is 0.12. So in this way, we have calculated these two values of X and Y. And yes, the most interesting thing is this fuse operator. So using this operator, actually what we have done, so simply we have combined that picture fuzzy numbers that we have collected from the different reliable sources. And ultimately, so we have implemented these fuse operations on these two picture fuzzy numbers. Now, how to implement the fuse operations? So as I said, that here we have focused much more on this neutral membership part, neutral membership grade. So we have considered that in the process, neutral membership grade may be associated with the positive membership grade, and on the other side, the neutral membership grade that we can attach, we can combine with this negative membership grade. Now see here, so in this expression, so we are trying to combine the neutral membership grade with this positive membership grade, and here the neutral membership grade we are trying to combine with this neutral membership grade. So in this manner, we have proposed this fuse operator. So that will be my main purpose of this operator is to combine the various picture fuzzy numbers which we are getting from the different reliable sources. And you see here for this neutral membership grade, nothing is there. So it is the most simplest, most in simple manner. We have aggregated the values using these fuse operators, whatever you are getting. Now, this is the example that actually the how we have computed these fuse operators for these various picture fuzzy numbers. So this is the positive membership grade, neutral membership grade, negative membership grade. And as per the expressions, what I have shown earlier, we have computed all these values. Now, ultimately, so we have found, we calculated the value of this mu, value of this eta, neutral membership grade, and ultimately value of this negative membership grade using this fuse operator. So also in our this particular study, we have utilized this GRA. So this is gray relational analysis. So this is very much important for this decision making purpose. So this is a significant part of this gray system theory that is introduced by Deng in 1982. Simply in GS system, so it represents a system where some part of the information is known and the remaining of the information may be unknown. Now, what is really happening? Due to the lack of information, so again, some information may belong to the gray area. Now, what is the main purpose that we are utilizing here this Demstar gray relational analysis in our this particular study? So actually the main thing is that, so if we notice what is the utility of GRA, simply the system is unable to provide any solution if the system does not have any information. And again, simply we can say that alternately, the systems may generate unique and acceptable solution due to the availability of the perfect information. But in the presence of either incomplete and partial information, what will happen? Then ultimately there will be the gray system, that will give us a variety of available solutions. So that was the main motivation behind that why we are utilizing this GRA. And this is the MCDM and GRA. So what are the contributions of GRA in any MCDM techniques? So as we know that, so in any of the MCDM methods, the criteria values of the various alternatives may be of different units. And once these are of different units, then maybe they have different influence in the decision-making process. Then what to do? So basically, due to this difference, actually, maybe there are maybe whatever results we are getting, the results are incorrect results if we don't take the proper care regarding this criteria values. So ultimately, so we are finding this normalization of all these performance values for all these criteria are unavoidable. Simply, we need to normalize the criteria to do some accurate decision making. So how to do it? So here we need this GRA. Now this is the analysis of GRA. So these three are the basically comparable sequences. These three are the comparable sequences. So these three comparable sequences we are using in our study to implement this normalization process. So if we look very so much closely, then we will see that these comparable sequences that is used to normalize when the maximum value as optimum 1 we are finding, and expression 7 it is used to normalize when it is required that minimum value as the optimum 1 behavior type criteria, and ultimately the expression 8, the last one, so it is used for normalization which is nearest to the pivot value and it is considered as the optimum. Actually, whatever we have done, so we have used this first one to normalize our this positive membership grade. This is for negative membership grade, and the last one, this is for the neutral membership grade. Now, this is the procedure of the GRA. Simply in GRA, what we are trying to finding out. So initially, we are finding that GRA coefficient that gray relation coefficient, and once we are finding the gray relation coefficient, then our task is to find that particular gray relational grade. So once we find, so this is the expression that how we are finding this gray relational coefficient. And once the gray relational coefficient is done, then we'll find out that gray relational grades. So using this expression, we can find out this gray relational grade. And so what is the weight? So you know that various criteria may have various weights. So this weights is associated with the criteria weights. But in this particular paper, what we have done, so for the sake of simplicity, we consider that criteria weights are equal for each and every criteria. Now, this is our proposed decision-making approach. So that is based on this picture fuzzy set. So what initially we have considered, so we have considered that some set of finite set of alternatives and some finite set of criteria. So ultimately, so we have find out that decision matrix in the form of this picture fuzzy numbers. And so then what we have done, ultimately then using the fuse operations, we have merged, simply we have aggregated all the criteria information for an individual alternative. So ultimately that will result to a collective picture fuzzy numbers. So that we have done using the fuse operation. So once the aggregation part is over, so next we have applied this GRA. So ultimately, once we have applied the GRA, so it is computing the comparable sequences for each and every alternative. Ultimately, in turn, we'll get the this gray correlation coefficient, and ultimately which will give us that gray relational grade, and then we are finding the actual gray relational grade. And based on the value of this actual gray relational grade, simply we are finding the rank for the various alternatives. So this we have the entire process, whatever we have proposed, the decision making approach, so we have applied it for COVID-19 medicine selection. So, and very briefly, we know that no specific treatments have been approved for this COVID-19 affected people. So we know that a few medicines are there. So actually, for the purpose of our experiment, we have considered these medicines. So this medicine 1, 2, 3, 4, and also we have tried to explain when these various medicines are required. And but again, we know that again the long-term safety therapies that is related to the treatment procedure of COVID-19, that is still unknown. Again, researchers are trying their best to find out that which medicines will work for a particular patient, but yet again many works have to be done here in this particular situations. So along with those medicines, we have considered four major factors. So these are our factors that we have considered along with these medicines. And what we have thought that experts apply these therapies based on their past experience without any strong evidence. So ultimately that, so the opinions of the experts, so using related to these therapies and to these to these factors, simply we have represented it using this picture fuzzy set. And we have collected the information regarding this and from some reliable sources. And then what we have done, so ultimately here, actually we know that once, although we are for the experimentation purpose, these medicines and these factors, but again we should know that FDA, that Food and Drug Administration, has not approved any those medicines as a regular medicines. Okay, but ultimately the FDA, they primarily gave the permissions to use those medicines for the emergency purpose. So now what we are trying to do, so once you see, so actually this is the medicines and these are the various factors associated with the medicines. So simply this is the matrix that we are finding from some reliable source. So ultimately we are applying this fuse operator. So we are finding this collective decision matrix based on the working principle of these fuse operators. Next, what we are doing, so we are finding the compatibility sequence. So these are the compatibility sequence that is the part of this GRA from this compatibility sequence, we are finding the gray relational coefficient, and these are the gray relational coefficient, and based on that, we got that actual gray relational grade. And so based on that grade, so we find the ranking order of the various alternatives. And actually, that was the brief of the work what we have done in the I think 6 months back, and recently that is published in the Soft Computing Journal. So within this short time, so I tried my best to actually to explain that what actually we have done in this particular case. So with this, so actually it's 11:45. So actually, thanks to the organizers, and particularly thanks to the audience, thanks to the participants for listening me for this half an hour. So this is my contact number and email ID. So now, if anyone have any doubts, so you can ask me. So I will clarify within the short timing. Again, if you have further more queries, so please drop me an email and please message me in this contact number. Obviously, I will reply.
Thank you, Dr. Das. The talk was really interesting, and I mean, we would definitely go through the paper and study this in more details. Okay. Meanwhile, anyone has any questions from the audience? Any clarification? Anything? Okay, if you don't have any questions right now, Dr. Das has already shared his email ID, so you can contact him if you have any doubts. So I just have a small question. How can we extend this work, or what are the future scopes in this area?
Yes, sir. Yes. So yes, sir. Actually, whatever we have thought that since we are working with a very small data set,
Yes.
so but ultimately once the data set will be huge, that means so that once we will work on that. Normally, since this is not approved by this FDA, so we have not considered all these things. But ultimately, in the near future, so maybe that many medicines will be available and many associate factors will be there. Then we are planning that we want to apply that regression analysis, and basically we want to attach that fuzzy regression analysis. So again, with this particular work, so to extend it. So once the data set will be used.
Okay, fine. Okay, thank you, sir, for the nice talk. So over to Professor Shom.
Thank you, our speaker Sujit Das, and the chairperson, Dr. Pratik Chattopadhyay. So it was really a very good, wonderful talk by Dr. Sujit Das, and hope everybody has enjoyed. And certainly something good will come from the side of the students. They can do and they can join. Now I